Hi everyone, welcome to my Max Academy. So in this session we will continue on polynomials for 10th standard CBSE. So last class or in the last video what we saw was a polynomial of degree n will have at most means maximum, at most n zeros. So what it means is a polynomial of degree 2 will have maximum of 2 zeros, right? Which means it cannot have more than 2 zeros. It can have 2 zeros or 1 zero or no zeros. It cannot have more than 2 zeros. It can have equal to 2 zeros or less than 2 zero, which means 1 zero or 0 zeros. Similarly, any polynomial of degree n, or if you take a polynomial of degree 3, will have at most 3 zeros. Not always equal to 3 zeros, but the maximum it can have 3 zeros. It can have less than 3 zeros. Right? So I'll give you a few examples. Okay, well, let's take a quadratic equation. Let's take an equation p of x, right, equal to a quadratic polynomial. I mean, which is suppose x square minus 7x plus 10. Now we need to find the number of zeros of this polynomial. Now when you find the zeros of the polynomial, we will take the polynomial, we'll put it equal to 0, and we have to solve for this, and which means we need to factorize the quadratic equation by splitting the middle terms. And I assume you all are having the knowledge of factorization of quadratic equation. If not, I will have a video which you can watch for knowing how to factorize a quadratic equation, which I will mention it in my comments or in the link. So now if we factorize this x square, so this 7x can be written as, which means I need to split this as two terms in such a way that if I multiply the two terms, right, I should get 10, and same two terms if I add I should get 7x, so which I can write it as 2x minus 5x plus 10 equal to 0. Now if you just see the numbers, 2 and 5, so minus 2 into minus 5 is plus 10, minus 2 plus minus, if I add minus 2 and minus 5 I will get minus 7, if I multiply minus 2 and minus 5 I should get this plus 10, right? So basically here it is 1. So you should get, so 1 into 10. So when you multiply two numbers, you should get 10. This is 1 into 10. And the same two numbers, if you add, you should get minus 7. So if you add, you should get minus 7. So the two numbers are 2 and 5. And so when I add, I should get minus 7. So both have to be minus. So minus 2 into minus 5 is 10. Minus 2 plus minus 5 is minus 7. That's how the splitting term is there. So if I take x common, I'll get x minus 2. Then if I take here minus 5 common, I'll get x minus 2 equal to 0. Then again, if I take x minus 2 common, I'll get x minus 5 equal to 0. So which means x minus 2 equal to 0 or x minus 5 equal to 0, which gives you x is equal to 2 or x is equal to 5. So which means this quadratic equation or quadratic polynomial, when you put equal to 0, then it is called as an equation. If there is no equal to 0, then it is called as a quadratic polynomial. This quadratic polynomial has two zeros. The two zeros are 2 and 5. This is 1 0, this is another 0. So it has two zeros. The two zeros are 2 and 5. So it has two zeros. The two zeros are 2, 0, 1 0, 0, 0, 0, two zeros. Let's take an example. See, here it is equal to 2 zeros. A polynomial of degree 2, which is a quadratic polynomial, will have maximum 2 zeros. Here it is having equal to 2 zeros. Now we will take an example where a quadratic polynomial will have only 1 zero. So let's take an example. Suppose if I take x square minus 6x plus 9. Suppose this is a quadratic polynomial. Now we need to find the zeros of this polynomial. Whenever we want to find the zeros of the polynomial, we have to put this polynomial equal to 0. So x square, then solve for x. You have to split the middle term again. So minus 6x can be written as minus 3x into minus 3x plus 9 equal to 0, because minus 3 multiplied by minus 3 gives me this 9, right? And minus 3 plus minus 3 should give you minus 6. So x is common, I'll get x minus 3, and minus 3 is common, x minus 3 equal to 0. So I'll get x minus 3 is common. So if I take x minus 3 common, I'll have x minus this 3 equal to 0. So which means x minus 3 equal to 0 or x minus 3 equal to 0, which means x is equal to 3 or x is equal to 3. In both the cases we got the same value, x is equal to 3. So x is equal to 3 is the only 0. So there is only 1 0, which is x is equal to 0. So this has only 1 0. So continuation of this is, so, or I can write it here. So we got continuation of this, I will write it here. Right, let me erase this. So continuation of this is, so therefore x is equal to 3 or x is equal to 3, which means x is equal to 3 is the only 0 of the polynomial. Okay, so x is equal to 3 is the only 0. So this polynomial, quadratic polynomial, has only 1 0. But this quadratic polynomial, it had 2 zeros, which we found in the picture. So this quadratic polynomial has only 1 0. This is an example of quadratic polynomial having 1 0. Now, if you want, now let's take another polynomial. P of x is equal to the third one. I call this as the first one, this as the second one, and I take this as the third one, where my P of x is equal to, suppose if we take x square plus 4. We need to find the 0 of this polynomial. How do you find the 0 of the polynomial? We have to put this value equal to 0. So x square plus 4 equal to 0 and solve for x. Then get x square is equal to minus 4. This plus 4 goes this side, it will become minus 4. Right? So which means now what we are seeing is, we are seeing a square of a real number. Right? X is a real number. The square of a number is always positive. It cannot become negative. So you cannot find any x such that if you square that x, if you square that number, you will get minus 4. Then we may think about 2 or minus 2. Right? If x is minus 2, what is x square? X is minus 2, suppose. X is minus 2. What is x square? X square will become minus 2 the whole square. What is minus 2 the whole square? It is 4. So x square becomes 4. So x square never becomes minus 4. So the square of a number, since you are in 10th standard, you will be only restricted to real numbers. So let's say I'm just calling it as a number. So a real number, the square of a real number cannot be negative. Therefore, no x will give you minus 4, or no x will give you x square plus 4 equal to 0, or x square equal to minus 4. Whatever value you put for x, you can never get minus 4. Even if you put 2, you will get 2 square, which is 4. If I put minus 2, then also minus 2 the whole square is plus 4. Only we get plus 4, we don't get minus 4. X square will never become negative. Therefore, this does not have any 0. Therefore, P of x does not have any zeros. Any zeros. Does not have any zeros. So we have seen an example where quadratic equation has 2 zeros. This quadratic equation has 1 0. This quadratic equation have no zeros, or does not have any zeros. Right? So now we will move on to the next section, which is called as geometrical meaning of 0 of a polynomial. So that is geometrical meaning of 0 of a polynomial. Right? So till now what we were seeing is the 0 of the polynomial again, but it is algebraically what the 0 of the polynomial be. We know 0 of the polynomial is the value of x, which will make the value of the polynomial 0. Right? That is the 0 of the polynomial algebraically. Algebraic meaning of 0 of the polynomial. Now this is geometrical meaning of 0 of the polynomial. Geometrical meaning means graphically. Graphical meaning of 0 of the polynomial. So using graph, what does 0 of a polynomial mean? Right? So what means is, if I define that geometrically, what is the meaning of the polynomial is the 0 of a polynomial. 0 of a polynomial is the x coordinate of the point, where the graph of p of x intersects or meets, intersects the x-axis. So what is 0 of the polynomial means? This is geometrical meaning. Geometrically what it means? It is the 0 of the polynomial is the x-coordinate of the point where the graph of the polynomial p of x intersects the x-axis. Right? Polynomial, you can say p of x. Right? 0 of the polynomial p of x is the x-coordinate of the point where the graph of p of x intersects the x-axis. So we'll do one example to understand this definition. So it may be a little confusing, right? So let's take an example. I'm just taking the same thing which is given in your book in page number 22. Suppose a p of x is this. Yeah, p of x is equal to 2x plus 3. P of x is equal to 2x plus 3. We need to find the 0 of the polynomial graphically or geometrically, right? So what we need to do is, see, algebraically you know how to solve this. Algebraically, how do we solve this? We will put this is equal to 0, right? Whenever you want to find 0 of the polynomial, you solve for x. So you get 0 minus 3, the plus 3 goes to this side, minus 3, 2. So 2x is equal to 0 minus 3 is minus 3, x is equal to minus 3 by 2. So minus 3 by 2 is the 0 of the polynomial. Now we are going to see this in terms of graph. Using graph, we are going to find this. That x is equal to minus 3 by 2 is the 0 of the polynomial. This is algebraically solving and finding the 0 of the polynomial. Now what we are going to do now is geometrically understanding the meaning of 0 of the polynomial or finding the 0 of the polynomial. Now to find the 0 of the polynomial, what we do is graphically, to find the 0 of the polynomial graphically, whatever the polynomial is given, we will take that as y. Put y is equal to 2x plus 3. Your p of x is called as y. Right? Then we need to draw the graph for this polynomial. We need to draw the graph for this equation, y is equal to 2x plus 3. And it is a linear equation in one variable, which you would have studied in your 9th standard. So which means when you draw the graph for this, you will get a straight line. When we draw the graph for this, we will get a straight line. Let's try to draw the graph for this. How do we draw the graph for this? We generally put the box, right? And we know it's a straight line, so 2 points is enough to find the graph, but we will always go for 3 points. 2 points is enough. So because when you know 2 points, you can always draw a straight line, and the graph of this is a straight line. So whenever you find 2 points, then you can plot those 2 points on the graph and get a line, but we will go for 3 points. That will make sure that our graph is perfect or 100% correct. Right? Sometimes if you take 2 points and if you make a mistake, we'll always get a line. So I suggest you to find 3 points. So x, y. Now we need to find 3 points. X, y. 1, 2, 3. This combination is 1 point. This is 1, 2, 3 points we have to find. How do you find that? We will put different values for x. So we will first put x is equal to 0. So put x is equal to 0 in this equation. What is my y? My y is 2x plus 3. If I substitute x equal to 0, I will get y is equal to 2 into 0 plus 3. So in the place of x, I am substituting 0 and finding what is the corresponding value of y. So y becomes 2 into 0 is 0, 0 plus 3, right? So y becomes 3. So when x is 0, my y is 3. Now I'll put x is equal to 1. When x is 1, when x is equal to 1 or put, when x is equal to 1 or put x is equal to 4. Doesn't matter. You can say put x is equal to 1 or when x is equal to 1. You can say put x is equal to 1. Let's put x is equal to 1. You can put any value for x. 1, minus 1, anything. Right? And correspondingly find the value of y. So y becomes what? 2x plus 3. So y is equal to 2 into x. X is 1. 2 into 1. So 2 into 1 is 2. 2 plus 3. So y is 5. So when I put x is equal to 1, my y is 5. When I put x is equal to 1, my y becomes 5. So 1, when x is 1, y is 5. Then we'll put, maybe we can put x is equal to, we can put 2 or we can put minus 1, doesn't matter. Anything we can put. I'll put x is equal to minus 1, suppose. So minus 1. So what is my y? Y is equal to 2x plus 3. Y is equal to 2 into x is minus 1. Minus 1 plus 3. I'm substituting x equal to minus 1 in this equation. So minus 2, 2 times minus 1 is minus 2 plus 3. And y becomes plus 1. So when x is minus 1, y is 1. Now we are going to plot the points. So what are the 3 points? 0, 3, 1, 5, minus 1, 1. We need to plot these 3 points in the graph. So we'll draw a graph. You all have to do this in a graph sheet. Right? So please have a graph sheet. I'm just doing, you think this as my graph sheet. Okay? So this is the origin, 0, 0. Now this is x axis. Right? Negative x axis, y axis. So I'll take 1, 2, 3, 4, and this is minus 1, minus 2, minus 3. Then I have 1, 2, 3. I can even put 4, right? So we need till 5. So we should have at least 5. So here I'll put 5. Y axis, x axis, negative x axis. Now negative y axis, this is minus 1, minus 2, minus 3. So this is my graph sheet. You think this as my graph sheet. Now we need to plot the point. What is the first point? 0, 3. I assume you all are comfortable in plotting the points in the graph sheet. 0, 3. So x is 0, y is 3. X is 0 here. 0, x is 0. Then I have to keep this finger on y. Y is 3 is here. So both you have to move so that they meet. So it comes here. So this point is 0, 3. Now 1, 5. 1 is here. And 5 is here. So move both the fingers. This one and this one up. So this point is 1, 5. This is 1, and here my y is 5. Both the lines. So y is 5, x is 1. They meet at this point. So this is 1, 5. Then minus 1, 1. Minus 1 is here. X is minus 1 and y is 1. Y1 is here. This is minus 1, 1. Minus 1 and 1, they meet here. This is this point. Clear? So this point is, this is minus 1, 1. This point. Now join these points to a straight line. It will go like this. Clear? When you join all the 3 points, you will get a straight line. Extend them. Now we have drawn the graph for the polynomial p of x. What is this? This is the graph. We draw the graph for p of x. So this is a graph for this polynomial 2x plus 3, and it is a linear polynomial because the degree is 1. Highest power of the variable is 1, so it's a linear polynomial. And if you draw the graph for a linear polynomial, you will always get a straight line. Right? Now we have drawn the graph of the polynomial. So this line is called as the graph of the polynomial. The graph can be anything. It can be a straight line, it can be some curve like this, or it can be a parabola, U-shape. It's called as a parabola. That we'll do different graphs. You will know, right? Or we'll see different graphs. Now this is a graph of p of x. Now as per the definition of the geometrical meaning of 0 of the polynomial p of x is the x-coordinate of the point, where the graph of p of x intersects x. Where is the graph? This intersects x-axis, intersects at this point. What point? So I'll put this as some x. It intersects at this point. Right? The graph of intersecting the x point at this point. So what is the coordinate of this point? Now if you see in your graph sheet where this is cutting, you will see that it is cutting at the point minus 3 by 2 comma 0. What is this point? This point will be minus 3 by 2 comma, so this point. This point will be minus 3 by 2 comma 0. So that is this point. Now as per the definition, you have to see the x-coordinate of the point. X-coordinate of the point where the graph of the polynomial intersects the x-axis. The graph of the polynomial, this line, it intersects the x-axis, which means or cuts the x-axis or meets the x-axis at this point. And in this point, what is the coordinate of the point? Minus 3 by 2 comma 0. Now we need to check the x-coordinate. See, your y-coordinate will be always 0 because we are taking a point on the x-axis. Any point on the x-axis, its y-coordinate is 0. That's why y equal to 0 is called as x-axis. Equation of x-axis is y equal to 0. So here, so now we need to check the x-coordinate. X-coordinate is minus 3 by 2. So this is the 0 of the polynomial. Minus 3 by 2 is the 0 of the polynomial. Which we solved, we got this. Here you can find using graph the same value. You need to just see where the graph is touching the x-axis or meeting the x-axis. Take the point, go to the x-coordinate of the point. That x-coordinate of the point is the 0 of the polynomial. Clear? Fine. Now we will do one more graph for quadratic polynomial. Now let's take one more example. Right? Now I'm going to erase all this. Now let's take an example of the same thing that is given in the book so that it is easy for you to understand. So I am at page number 223. Sorry, page number 23. We are going to draw the graph for the polynomial. So p of x is x square minus 3x minus 4. We need to draw the graph for this polynomial. So here it is a quadratic polynomial. So obviously we will not get a straight line like this. We will get some curve which is called as a parabola. It will be like a U-shaped one, which you can see in page number 23, figure 2.2 in your textbook. Right? So we need to draw the graph for this. I told you, whenever a polynomial is given, we have to take y equal to x square minus 3x minus 4. We take the entire polynomial p of x as y, put y equal to. Then we need to substitute different values of x and find different values of y. And don't restrict yourself to 3 points. We'll go for 3 points only if it is a linear polynomial where we get a straight line. So, but here it is a quadratic polynomial, so we have to go for 5 pair of points or 6 or 7 points. 7 set of points we need to go. Right? So generally we will go with 0, 1, minus 1, 2, minus 2. Then after that, depending on the graph, we will go for other points that I will teach you now. So now we are going to find the 0 of this polynomial using the graph. So let me erase this. Erase these. Now we are going to, I'll put some more tables. I'll erase this. So okay, let me start from here. So that if required, I can extend this. Right, so x, y. 2, 3, 4, 5 is definitely needed. If you need some more, we'll extend the box. Right? Now what do? We'll put different values of x and find different values for y. So I'll put now x is equal to 0. If I put x is equal to 0, here what is my y? So put x is equal to 0, then my y is what? X square minus 3x minus 4. So if you put x is equal to 0, I'll get y equal to 0 square minus 3 times 0 minus 4. So y is equal to 0 square is 0, 3 times 0 is 0, minus 4. So finally you'll get y equal to minus 4. So when I put x is equal to 0, I'm getting y equal to minus 4. So this is the first point that we got. Right? So similarly, let's put x is equal to 1. Then my y becomes x square minus 3x minus 4. So that becomes 1 square minus 3 into 1 minus 4. So 1 square is 1, 3 times 1 is 3 minus 4, which is minus 6. So when I put 1, when I put x is equal to 1, I'm getting y equal to minus 6. So this is the second point. Okay. So similarly, let's put x is equal to minus 1. Then. So always try for 0, 1, minus 1, 2, minus 2. For these 5 points, these values, so you can even put 0, 1, minus 1, 2, 1, minus 2. Then if required, we'll put other points depending on how the graph is. Then I'll teach you. Now x is equal to minus 1. If I put x is equal to minus 1, my y equal to x square minus 3x minus 4. So my y becomes, x square means minus 1 the whole square, minus 3 into minus 1 minus 4. So which means in the place of x, I am putting minus 1. So you have to put minus 1 the whole square. Don't put like this. X square is this. So if you put x equal to minus 1, don't write like this. This is wrong. When you are substituting for x is equal to minus 1, you have to put minus 1 the whole square. Because you are substituting for x, entire x is minus 1. So minus 1 square is 1. Minus 3 into minus 1 is plus 1, is minus 4. My y becomes what? Minus 2. Right? This plus 2, 2 minus 4 is minus 2. So when I put x is equal to minus 1, I'm getting my y as, oh sorry, I mistake. So minus 1 square is 1, 3 times 1 is 3, minus 4, so you get 0. Sorry. So 3 into 1 is 3, right? So when I put x is equal to minus 1, sorry. When I put x is equal to minus 1, I am getting y as 0. Right? Now we'll put x is equal to 2. Now put x is equal to 2. When x is 2, what is y? Y becomes x square minus 3x minus 4. So y is equal to 2. 2 square minus 3 into 2 minus 4. So 2 square is 4. 3 times 2 is 6 minus 4. You will get y is equal to minus 6. So when I put x is equal to 2, my y is minus 6. Right? Now let's put minus 2. Right? If I put minus 2, what do I get? So we need to extend this. Let me erase this. I'll erase this graph. Now we will put, next one is, we need to put x is equal to 2 minus 2. So put x is equal to minus 2. So my y is equal to x square minus 3x minus 4. So y is equal to, in the place of x I have to put minus 2. So if I put minus 2, then I will get minus 2 the whole square. So you have to put minus 2 the whole square. Don't put minus 2 square. Right? Don't put like this. Minus 2 square. That's wrong. I have to put minus 2 because you are substituting for x as minus 2. It is minus 2 the whole square minus 3 into minus 2 minus 4. So wherever x is there, I am putting minus 2. So minus 2 square is plus 4. Minus 3 into plus 2 is plus 6. Minus 4. My y becomes 6. So when I put minus 2, I get 6. Now let's try to plot these points. Then based on that, we may need to add some more points. Right? So let's put the graph for this. So right, x-axis, y-axis, this is 1, 2, 3, 4, and this is minus 1, minus 2. So all of you have to do these in your proper graph sheet so that you get it properly. I mean, I am just doing, on the board, I am just creating my own graph sheet and trying to plot the points, but you take the graph sheet and, accordingly have these 4 quadrants and then, name the points, so mark the points. 1, so 2, 3, 4, 5, I think 6, goes till 6. So if required, we will extend this. For now it is 6. So here it is minus 1, minus 2, minus 3, minus 4, minus 5, because it is going till minus 6. So we should at least have till minus 6. This is my negative y. Positive y, negative x-axis, positive x-axis. So we need to plot these points. So what is the point? 0, minus 4. So 0, this is 0. 0. So 0, minus 4 will come. This is 0, minus 4 here. So this is 0, minus 4. I am putting in dark circle. Then 1, minus 6. 1 and minus 6 will come here. This point is 1, minus 6. Okay, so this is 0, This point is 0 comma minus 4. This point is 1 comma minus 6. Then minus 1 comma 0. Minus 1 comma 0 is here. This is minus 1 comma 0. Right? Then 2 comma minus 6. 2 and minus 6 is here. So it come here. This is 2 comma minus 6. This point is 2 comma minus 6. I'm putting little dark, a big circle so that you know. Right? So you have plotted 4 points. 1, 2, 3, 4. These 4 you have plotted. Now minus 2 comma 6. Minus 2 and 6 is here. Minus 2 is here, 6 is here. So they will come here. So join all of these using freehand. So all these points. So this point, drawing this, joining this, then going here, and going here and taking a turn. See, whenever you draw a graph for a quadratic polynomial, you will get a U-shaped curve, either like this U or like this. Right? So this one is like kind of, we have got half of the U. We have to complete the graph. We need to put some more points so that it looks like this. This shape is called as parabola. The shape of the curve is called as parabola. So whenever you draw the graph for a quadratic equation, the graph you will get is a parabola, which is a U-shaped. It will be like a U, or it will be the reverse U or the inverted U. Either it will be like this or like this. Right? So this the shape of these curves are called as parabola. You will study more about parabolas in your 11th standard. That comes under conic section in 11th standard. Anyway, so I'll erase this. So we need to now, we need some more. See, we want the curve has come this side. We want the curve to go this side. So it means we need to take some points here. So let's put x is equal to 3, because you want the curve to come like this. You want the curve to be like a U. So take a point x is equal to 3. Put x is equal to 3 here. So we need some more points. Now put x is equal to 3. X is 3. When x is 3, what is our y? Now again put x is equal to 3. Put x is equal to 3. Right? So if I put x is equal to 3, what is my y? Now y equal to x square minus 3x minus 4. Y is equal to, I am putting 3 square minus 3 into 3 minus 4, which is 9 minus 9 minus 4. So my y becomes minus 4. So when I put x is equal to 3, my y is minus 4. So 3 means minus 4. Now plot the point 3 comma minus 4. So 3 is here, minus 4 is here. So this is 3, this is minus 4. So this point, this is 3, this is minus 4. This is the point. So again, so which means what? The graph is going up. So we still need to take a point after 3, which we'll take 4. We should get a proper U. Till that we have to do. So 4. If I put 4, what do we get? I'll do here for 4. Okay. So put x is equal to 4. My y is what? X square minus 3x minus 4. Now my y is equal to minus 4 square. Sorry, 4 square minus 3 into 4 minus 4. So 4 square is 16 minus 12 minus 4. I get 0. So which when my y is 0, when my x is 4. When I substitute x as 4, I am getting y as 0. Plot the point 4 comma 0. 4 comma 0 will come here. This is the point 4 comma 0. So this is 4 and y0 is here. X is 4. So you see that the graph is going like a U, right? This point is minus 3 comma minus 4, right? 3 comma minus 4 is here. This point is 3 comma minus 4, this point, and 4 comma 0. Then we should take one more point. We'll take the fifth 5. We'll take the point 5. Now put x is equal to 5. Now when x is 5, when x is 5, what happens? What is y? When x is 5, so where shall we do that? We don't have space. I don't want to erase anything. So we'll do here. Okay. Now when x is 5, put x is 5. So y square equal to x square minus 3x minus 4. Sorry, y equal to. So y equal to. So 5 square minus 3 into 5 minus 4. So 5 square is 25 minus 15 minus 4. 25 minus 15 is 10. 10 minus 4 is 6. So y becomes 6 when x is 5. So we have to plot the point 5 comma 6. 5 is here, 6 is here. So it will come here. So you, and if you keep on going, so you can put like this. You can put like this. So this is the graph for the quadratic equation x square minus 3x minus 4. Now we need to find the zero of this polynomial. Zero of the polynomial, geometrical meaning of zero of the polynomial. What is geometrical meaning of zero of the polynomial? It is the coordinate of the point, is the x coordinate of the point where the graph of p of x intersects the x axis. Now this graph, which is like a U shape, right? This U shape, it is intersecting the x axis in how many points? It intersects as 2 points. This point and this point. This curve is touching the x axis. This line is your x axis, right? This is your x axis. So this is the graph of the polynomial p of x. It is touching at 2 points. So this has 2 zeros. So how many other places the graph is touching the x axis? Those many zeros are there for the polynomial. The earlier polynomial, it was a straight line where it intersected the x axis at only 1 point. So the zero was 1. Now here it is intersecting at 2 points. So the number of zeros is 2. So this polynomial has 2 zeros. This quadratic polynomial has exactly 2 zeros. Now what are those zeros? Now you need to find the point. So what is this point? This point is minus 1 comma 0, this point, and this point is 4 comma 0. Now we need to check the x coordinate. What are the x coordinates? Minus 1 and 4. So for this the zeros are minus 1 and 4. I can write it down. The zeros are zeros. You can say it has 2 zeros. It has 2 zeros. 2 zeros. It means that polynomial p of x has 2 zeros. The zeros are the x coordinate of the point where the graph is intersecting the x axis. So minus 1 and 4. Minus 1 and 4. So these are the 2 zeros of this polynomial. Clear? Fine. So how many other places the graph of the polynomial is touching your x axis? Those many zeros are there. Sometimes they'll give the polynomial, you can draw the graph and find out. And sometimes they'll just give only the graph. From the graph, they will ask you how many zeros are there, which you can see in example 1 in your textbook in page number 27. So let me erase this. We will try to find the zero of the polynomial by looking at the graph of the polynomial. They will give the graph of the polynomial. Looking at the graph of the polynomial, you can find how many zeros are there. Right? So let me erase this. Let's take a polynomial. I am going to your example 1. So example 1 in the textbook. Right? There are 6 graphs given under example 1. Looking at the graph, we need to tell how many zeros are there. How many zeros a particular polynomial has. What is given is the graph of the polynomial is given. So now I am taking the first graph, the first one. The graph is something like this, right? It goes here, then it goes down, and then it goes like this. Something like this. The first graph in example 1. EG1 means example 1. EG means example. So example 1 in page number 27 in your textbook. Page number 27 and example 1 first graph. Now we need to see how many points in how many places. This is the graph of the polynomial. The graph can be anything. It can be a straight line, it can be a parabola like this, or it can be any unknown curve like this. Now how many places this curve is touching? This is your x-axis. Y x-dash. Now how many places this curve is touching the x-axis? At only one place. This is touching at only one place. So this has, we will say, the graph of p of x intersects the x-axis at only one point. So the number of zeros of the polynomial, P of x is 1. How many zeros are there? Only 1 0, because it is intersecting the x-axis. Don't look at whether it is intersecting the y-axis or not. That doesn't matter. How many ever places this is a graph of the polynomial. This is a graph of the polynomial. This curve is touching the x-axis at only 1 point, so this has only 1 0. Now let's look at the second one. Let's look at the second graph under example 1. So what is the second graph? The second graph under the same example 1. So how does it look? It looks like this. Right? So this is your origin. O, and so here also you can put O, doesn't matter. That is O point, doesn't matter. Now x, y, y dash, so x dash and y dash. Now this is the graph of the polynomial. It's a U-shaped curve, so you know that it is a quadratic polynomial, because whenever you see like this inverted U, reversed U, or upward U or downward U, then the polynomial is a quadratic polynomial. But anyways, here we need to see the number of zeros. Now number of zeros, how do you find? How many places this graph is touching the x-axis? It is touching at this point and this point. Right? Those 2 points it is touching. So we will say the graph of P of x, or the graph of the polynomial, whatever. Polynomial is what is P of x. Graph of the polynomial intersects the x-axis at 2 points. Therefore, the graph of the polynomial intersects the x-axis at 2 points. Therefore, the number of zeros of the polynomial, number of zeros of the polynomial is 2. It has 2 zeros. This is 1 0, this is another 0. Right? So just you need to look at how many places the graph is intersecting the x-axis. So check how many points and those number of zeros that polynomial will have. So I will request you guys to do the other graphs, the third graph, fourth graph, fifth graph and sixth graph in example 1. So try this as a homework, and if you have any question you can post in my comment section, or you can WhatsApp me. This is my number 9884036077. You can WhatsApp me. I will try to clarify as much as possible, as quickly as possible. And then exercise 2.1 also you give it a try as a homework, but I will definitely do it in the next video. Exercise 2.1, I will do it. It is similar to this. How many places the graph is touching the x-axis? Fine. So we will stop in this session and we will meet in the next video. Thank you for watching. Bye.